Thank you very much. My apologies, everyone, for the delay earlier. Technical challenges working around the world. I'd like to thank the Jordan Engineers Association for this opportunity to share with you what we're doing to equip our engineers at the University of Alberta in terms of process safety management. So my presentation today, here's a brief overview. I'll speak briefly about our School of Engineering Safety Risk Management that we have at our university. Then I'll cover two courses. One is our leadership course, Engineering 404. And our second one, which is our process safety management course, is Engineering 406, which covers more methodology and tools. And I'll go into that course in more detail. Then I'll have some conclusions and some closing thoughts. So in terms of our school, like most organizations, we have a vision, as you can see here, in terms of taking risk management to the next level. And for us, it's about providing organizations with leaders in engineering safety and risk management through exceptional teaching, researching, and advocacy. And you can see our strategic priorities listed here. And one of the key ones is working with an industrial executive board to help shape and form the teaching we provide for our students. And then we're underpinned, as you can see at the bottom of my presentation here, by 4 pillars. In terms of what we do at our school at the University of Alberta, we work with a number of industries here, particularly in Western Canada. So you can see on the top left-hand corner, we do a lot of work with the mining sector. Also, within the health services sector, risk management is a big part of the healthcare profession. We work with traditional industries such as construction, the railway sector. Railway is very big in Canada. It's a very large country, and we move a lot of product by rail, and a lot of that product is hazardous. We work with the oil and gas industry, as the industry is quite big in Western Canada, along with secondary processing such as fertilizers and plastics, etc. And then most recently, over the last few years, we've been working with the agricultural sector as well, in terms of some of the risks that they have to manage. So a very broad group of industries we work with in our school. In terms of our 404 course, which I'd like to speak to first, this course is taken by all of our engineers at the University of Alberta. So in a typical year, we graduate about 1,000 undergraduate engineers in a variety of disciplines, from traditional, such as mechanical, electrical, to some of the new emerging areas, such as nanotechnology, computer engineering, etc. And this course, 404, is focused on a leadership role as being a risk manager. A key aspect of the course is taking a major incident, as part of a term project with a team of other classmates, and taking a look at that incident to do a deep dive in terms of a root cause analysis, a very comprehensive report. And this slide provides an overview of the course. We start off with the fundamentals, making sure we ground our engineers in the fundamentals of safety and risk management. Then we talk about risk management systems and typical elements of a system, the tools that help support an overarching approach to risk management, incident investigation, a very important aspect of our course. We still believe most incidents are not adequately investigated to get to true latency and issues with, say, the organization in terms of risk management system. We support it with a number of case studies, not just situations where there was some sort of tragic outcome, but also good news stories, such as the leadership at Alcoa. Then we talk about leadership in risk management. As we know, a number of engineers will go on to careers as leaders. We cover the aspects of the profession in terms of both legal and ethical aspects that come with being an engineer in the context of risk management and safety. And then you can see here, we have a number of guest speakers from a number of organizations that come in and speak to how they practice risk management in their organizations. This slide here, I'd like to switch over to our course now we call it 406, methodologies and tools, but it's really much more of a course in risk-based process safety. This course is a technical elective, typically taken by senior year chemical engineering students for the most part in their last year prior to graduating. The course itself, in terms of what we teach, has been closely developed by working with practitioners from industry. We rely heavily on a number of case studies for teaching, and we have a number of lecturers that come in for seminars and lectures from industry. The outline of the course as provided here, it starts with the concepts of understanding hazards, hazard identification. Inherent safety is a key underpinning of good design. Transition into design in terms of considerations, that is a big part of what engineers do to be engaged early. We speak to a number of aspects of operations such as MOC, human factors, pre-startup safety reviews. And you can see here, as I mentioned, a number of these topics and themes. You can see some of the case studies that go with these. For operations, we also tour a local refinery with the students. We have a whole section on alarms and layers of protection, safety instrumented systems, etc. And we tie that into the tragic incident at Texas City. We cover safeguarding, and then quite a bit on risk assessment and a number of tools that are used throughout the industry. The students have a practice to not just learn, an opportunity not just learn about the tool, but practice those as well. Then we have what I call miscellaneous topics that don't quite fit into the 20 elements of risk-based process safety. And here is a listing of a number of our guest speakers that come in and support us. One thing we do in the course is case studies, and we've heard through a number of our speakers to date at the conference so far that there are many, many case studies available to us. What's interesting, traditionally in engineering, case studies aren't used a lot compared to some faculties such as, say, business and law and medicine. So we do a lot more work with case studies where students get to think about, well, what is this situation in the context of process safety, and what should and could be done about it. We particularly work with the CSB videos to give weekly quizzes based upon case studies, and those are tied in with the themes for the week. So it complements the classroom presentations quite well with these homework quizzes. For the assignments for the course, we take a much deeper dive into an application of a topic. So a good example, students will learn how to use the FMEA tool, or they'll do some overpressure protection calculations, that type of thing, has up. And early in the course,
Mr. Christopher, 2 minutes remaining, so that we can reschedule the other conference paper, please.
Okay, early in the course, we have foundational assignments, and we use the free materials from AICH. And then we have, as I mentioned, a number of guest speakers that come in for the seminars to help students. Guest lectures, lots of positive feedback from students. About 1/3 of the course has guests from industry and other agencies, including other professors from the university, such as toxicology, occupational health. It really helps give the students some insights and content in terms of how practitioners actually implement these tools that they learn about. So in conclusion, for us, for teaching, it's important to keep in mind that students are probably seeing this material for the first time. It's worked well to leverage off the CCPS work in terms of the risk-based process safety framework. We work heavily with industry to help validate our course content. We work with our local practitioners. Case studies have worked out really well in terms of helping students grasp the key concepts. And we believe we're equipping our students for skills that they can take to the real world. In conclusion, I'd like to thank the Jordan Association of Engineers for this opportunity to share what we're doing at our university.